Bismillahirrahmanirrahim. Mrs. Sobia Sohail is here with class second year maths. Assalamu alaikum. Hopefully you all are doing well. So this topic I'm starting for theorems on differentiation. The first rule for this one, that if you are taking derivative with respect to x, okay, what's the derivative? Rate of change of one quantity with the other quantity as the other quantity approaches to 0. Okay, so that is called the derivative with respect to x of a constant number always will be equal to 0. Okay, means derivative of a constant function always equals to 0. Second rule is that we are taking the derivative of a variable number and it has the power. So what happened, that its power will be written in the start, power minus 1, and the derivative of that function will be written like this. Okay, so this become 1, so it happens like n x n minus 1, and this is also called power rule in the differentiation. Power rule or power formula. Direct differentiation we are doing with that one. Okay, I will just first discuss these two rules and then I will do the relevant question from the exercise. It is with the unit number 2, exercise 2.3. Question number 1. That is, differentiate with respect to x. So question number 1 is, we can say let this function is the equal to y function, where y is dependent, x is independent function. X is independent, okay, y is dependent on x. We just suppose that this is a function of x and we say that this is equal to y. Sometimes we can keep it as function of x also, means as either we can write like this one or this one, both are same. Okay, usually I write it equal to y, this is my own style. So I suggest the same one, no problem. So differentiate with respect to x. When we are differentiating with respect to x, d by dx on this side and d by dx on this side, it means we are differentiating with respect to x on both sides. Whether we can write this in the statement form also. Okay, after this, it become dy by dx, and according to the power rule, derivative first we will separate the all. So in the start we can write coefficient first and derivative of the function, that is x cube, plus derivative of the function, that is x square. Apply the power rule, so it will be written in the start 4 power minus 1 and then derivative of function, plus this 2 is here, power in start, so it will multiply with its previously present coefficient, x power minus 1, and leaving the power we will take the derivative of the function, power in start and then power minus 1 and derivative of function. I'm just writing in the formal way. Next time we can do it in the like faster pace also. We can skip this step also and directly we can write the answer, because in every part we don't have enough time to explain this as it is. We must do the practice of this step once or twice, then directly we will do the other step. 4x cube, this will become 1. 2 3s are 6, x square, 1 2x, and this is the completely simplified derivative of the given function. Next, question number 2 is, we can also say let y is equals to the given function x minus 3 plus 2 times x power minus 3 by 2 plus 3. Okay, so whether I can write differentiate with respect to x as it is said in the question, and then d by dx of y, d by dx of x minus 3 plus 2 x minus 3 by 2 plus 3. Okay. Now we will differentiate each function. Okay. Once I will differentiate this one function, so I will apply the power rule on that. Power rule means write the power in start because it's negative power, that's why I will put the bracket. As it is the power minus 1, then differentiate the function without power plus coefficient multiply by power, then derivative function minus 3 by 2 minus 1 and derivative of function plus constant number. Constant number derivative is always 0. Then it will equals to this one minus 3 x x minus 4. Okay, then this is cancelled, so plus minus minus 3 x power minus 3 by 2 and minus 1 will become easy way. 2 ones are 2, minus 3 minus 2 minus 5, minus 5 by 2. Do mental calculation. Okay, so whether you can make this power positive, bring it to the denominator, or the answer as it is also can be kept. Okay, no problem. I will write minus 3 common, x minus 4 plus x minus 5 by 2. Because the question was including the negative power, we can keep that as it is. But sometimes we can keep the power positive. 1 over x4, it can be done like this, plus 1 over x power 5 by 2. So that the exponents are represented in the positive, with the positive exponents in the last. Terms are represented with the positive exponents in the last. Now, next question is question number 3. For that one, I would like to introduce before that the quotient rule. Yes, quotient rule in a simple way, I mostly teaching my students like derivative of this one. Okay, not with respect to u or v, because one variable is taking differentiation with the other variable. So simply I say v square u derivative of u derivative v as it is minus u as it is derivative of v. In the book, the reference is being given with f of x with respect to g of x, and the derivative is being taken as like this. How it is being solved? Denominator function square of that, and then denominator function as it is, derivative of numerator minus numerator function as it is, derivative of denominator function. Whatever is easy we can take. Okay, mentally you can keep this one in the mind, that is much easier. And in the book, and mostly author have given the reference of this formula, means f of x, g of x, both the functions including the same variable. Then you can apply the quotient rule in differentiation. The derivative of this one fraction is equals to like this one, and there is a product rule also which I will explain. Take it, u into v type. Yeah, so derivative is done, u as it is v derivative plus v as it is u derivative simply. Or in the function form, if you are writing f of x, g of x, how you are taking the derivative of the product? F of x as it is, derivative of second function, plus g of x as it is, derivative of first function. So this is called product rule for the derivatives. u v derivative plus v u derivative. So here also mostly I speak about this one and then use this one because it's easy to keep in the mind, u into v type. So now I will solve the question number 3 of exercise 2.3. It's given in the quotient form. Let again, whether you can write f of x or y. Y is equals to a plus x over a minus x. Okay. So here we will apply the derivative on both sides. On y, derivative on a plus x and a minus x, u over b. Okay, so when I will apply denominator square, denominator as it is, derivative of numerator minus numerator as it is, derivative of denominator. You can cross check like these two terms should be same. Okay, by this way also. So if we are solving it, a minus x as it is, and derivative of constant 0 plus derivative of x with 1 power will remain 1 minus a plus x, derivative of constant 0 minus derivative of x with respect to x 1, a minus x whole square. A minus x multiply by 1, yeah, it will remain a minus x, minus a plus x when multiplied by minus 1, this minus 1 minus minus will become plus. If you want to write it once more, so you can write, or when you have enough practice on this topic or you have enough command on this topic, then you can do the direct step also. Okay, so let me write once as it is, a minus x minus minus plus a plus x over a minus x whole square. It's okay. Next, a minus x plus, open the bracket, a plus x, then a minus x whole square. This cancel, 2a divided by a minus x whole square. So this is derivative of the given function is done. Thank you so much. Allah Hafiz. I will do the next part in the next video.